Hello together. This video explains you how you can change the parameters of an API Profinet slave system during operation. If you are looking here on my installation, you see here I have a 7 PLC and I have connected two API Profinet slaves. If I'm going online, you see everything is green and running. As we learned in a previous video, the API parameters are set inside the PLC. You see here the parameters of our VTUG WOV terminal. You see here the parameters of our MPIL WOV terminal. At the moment, we have here behavior fail state reset outputs. If you have a closer look on my live system, then you recognize here is the MPIL WOV terminal. The coils are switched on, and if I disconnect now the cable, the coils are off because of my parameter settings. To change the behavior during operation, you need a function block provided by Festo. This function block you are finding in the support portal of Festo, and if you have downloaded the function block, you can integrate it into your TIA portal. Just here you see the global libraries. You open the global library, you're going to the location where the function block is saved, and here, very important, change to compressed libraries, and then you can open and select the folder where it is, and in my case I have to override it because it was installed already, and then you are here in this area and you will recognize the function block is available for TIA version 50.1 and higher. Therefore we have here this upgrade button inside TIA portal. After a few seconds, the function block is upgraded for my system, which is TIA portal version 16 update 1, and it will be available here on the right side in the global libraries. If I open the function block, then I find here the S750 system, and inside this folder I see here my API parameter block. This parameter block I make drag and drop to my program blocks. And now I can use the function block inside my main OB1, for example. See it here, drag and drop it to the network 2, and then the function block will create an instance, and per default it is looking like this. First of all, here you have the execute button of the function block, which could be a variable, or in my case just some dummy. Then we have to know the API hardware ID. This is the hardware identifier of the Profinet slave. If we go here to device configuration, and for example we want now to change here the fail state behavior of the MPIL, we have to take the hardware identifier of the Profinet node, which is in my case 280. See here, this is the API Profinet node, the hardware identifier is 280. Going back to the main OB, I write here 280. The next one is the slot number. The slot number, again, going to the device configuration of my second slave. The slot number is located here. This slot number belongs to the API position of the module. And you see here, my slot number for my MPAL is 3. Next one would be the parameter ID. Therefore, we have a closer look inside the manual, and we will recognize in the module manual for the MPAL that the behavior in error state can be defined with the parameter ID 20052. The value 0 means reset outputs and 1 mean maintain status hold last state. It is instance 1. It is an unsigned integer with 8 means 1 byte. Going back to my project, you will see here now 2050, instance 1. But the block is starting the counting with 0. Means here 0 means instance 1 of the manual. That's the reason why I have to put here a 0 and not a 1. Here I define to read or write with the block. That means false, read, true, write. Therefore, I'm using now another dummy. So the length is 1 byte. And here I'm defining the data. I have done this already here in the PLC text. You see here API parameters, and here is the fail state for MPAL. It is here a byte, and I use here an unsigned short integer. So fail state MPAL. This is what I have to do, and now I'm making here a download to the PLC, and after a few seconds you will recognize that everything is running, and I can use the block inside my OB1 with the monitoring function here for testing purpose. First of all, moving this block off, moving this block here also off, making here this variable again to 0, and let us test the read functionality first. To read, this has to be false. I'm activating now the block, and you see I received the read length as 1 byte, the status 1 means everything fine, and the value is 0. The next step is to write, and therefore we want now to change here a little bit the direction. We are changing this here to 1. We are changing here the data format to 1 again, and then we execute the block one time and write now the fail state behavior to our MPAL. The block has done everything correctly. Everything is looking good for me. Now I'm going to my system and have a closer look what is happening. And you will recognize the MPAL calls are staying because I have now changed the fail state behavior of this block. And this is how you can change now during operation parameters of the API modules. What is very important, you see here I have disconnected the cable. If I'm connecting the cable again, the PLC is building up again the Profinet relation to our devices. And during a startup, he will write the parameters which are inside the GSDML. That means with the API parameter block, you can change parameters during operation. But after a power off on, this change will be overwritten by the PLC and the set parameters inside the module parameters of TIA portal. You see now, if I'm disconnecting it again, we have again the old behavior. This is important to know, otherwise you may get problems with your application program, but if you are taking account about this, then everything is fine. I hope this is useful for you and you have learned something. Thanks for your attention. Bye.